Okay, welcome back to WSHS Algebra 1 Virtual Tutor. Today's lesson is on scientific notation. So scientific notation you might have done a while back in middle school. You use this a lot in science as well. Scientific notation is just a shorter way of writing very, very large numbers. So we kind of shrink them down so that they're much easier to read for us. So we're going to treat the scientific notation because it has exponents here. Remember, you learned how to do multiplication with exponents and division with exponents. So we're going to use those rules again to do our scientific notation. Okay, so when we multiply scientific notation to multiply two numbers expressed in scientific notation, we're simply going to multiply our coefficients, which are the numbers out front, right? So I'm talking about these numbers right here. And then we would add our exponents. Okay, once we do that, we want to make sure that the final answer is written in proper scientific notation. So what I mean by that is proper scientific notation typically has a decimal between the first two numbers that are like greater than 0, right? And then we would have times 10 to some power. If I were doing my calculations and I saw my answer as 23.4, I wouldn't write this as my final answer with my scientific notation because the decimal's in the wrong spot, right? The decimal should actually be between the 2 and the 3. So you want to make sure you're careful with that. When I say proper scientific notation, that's what I mean right there. So let's take this for example. 5.1 times 10 to the 4th times, right? We know this is multiplication because there is no addition or subtraction between these parentheses. So we're going to multiply that by 2.5 times 10 to the 3rd power. So the rule says we can take our coefficients and we're going to multiply them. Remember before when we lined up our numbers there and then we have our exponents, right? Times 10 to the 4th and then 10 to the 3rd. These we're treating like if it said x to the 4th and x to the 3rd power. When we went ahead, lined them up, and then we added our exponents there. So 5.1 times 2.5 is 12.75. And then we would add the 4 plus the 3 here, so this would be 10 to the 7th. So far we have 12.75 times 10 to the 7th power. But remember, I said we have to make sure that it is in proper scientific notation. Do you see here how this decimal is not between the first two numbers? I need them to be between 1 and 2. So it needs to be 1.275 times 10 to some power. Now this power right here tells us how many times to move the decimal place, right? So if I were supposed to move 7 times, but I just went ahead and moved the decimal an additional time right here because it was in the wrong spot. So if I moved it to fix it by 1 space, then I can increase this by 1 space. So that would make it 1.275 times 10 to the 8th power. Okay, if you are unsure or that confuses you a little bit, we can go ahead and expand it the long way just to double check. So we said we had 12.75 times 10 to the 7th. Do you remember a while ago, this means you would move 7 spaces to the right because it was a positive number. So I would move this 1, 2, 3, 4, 5, 6, 7, and then I would fill everything in with zeros, right? So this is 1, 2, 7, 5. Then I would have 0, 0, 0, 0, 0. So if my decimal is supposed to be between the first two numbers here, 1 and 2, how many spaces would I need to move it over to write it in scientific notation? 1, 2, 3, 4, 5, 6, 7, 8. So this is still 1.275 times 10 to the 8th power. So that would be your answer. So either way, you can do it. You can expand it if you need to expand it, or you can do that little trick where if you move the decimal once, then you have to increase the exponent once. Okay? So let's try dividing then. Dividing numbers, so remember when we divide our exponents, we subtract. So the same rule applies here. So to divide two numbers expressed in scientific notation, we're going to divide those coefficients out in front, and then we're going to subtract the exponents. Again, we want to make sure that it is written in proper scientific notation. So your final answer should have the decimal between the first two numbers there that are greater than 0. All right, so example 2. We're going to take these two and we're going to divide them, right? So 6.2 divided by 3.1, which equals 2. And then we had 10 to the 6th and 10 to the 3rd. So we would subtract those exponents, right, with division after exponents. So it would be 10 to the 3rd power. So if I put these together, this would be 2 times 10 to the 3rd power as scientific notation. Now this one, I didn't have any decimals, so I could either leave it like this. Another way we might see this one is 2.0 times 10 to the 3rd power. Both ways are okay because both ways would give you the same exact answer, right? So if I had 2 times 10 to the 3rd, if I expanded it, that's going to give me 2,000. So they both work the same way. 2.0 times 10 to the 3rd. If I move the decimal 3 spaces, 1, 2, 3, it still gives me 2,000 here. So this one we didn't need to worry about moving our decimal because it all worked out for us well. So again, I have division, and I know it's division, remember, because if we see this fraction bar, fractions represent division here. So we want to divide these two numbers, 3.66 divided by 2.0, and we get 1.83. If I take these exponents and I subtract them, -5 minus -3, that's going to give me a -2. So this would be times 10 to the -2 power. And I can leave my answer like this because if you notice, this decimal is in the right spot. It's not after the second number. It is between the first two numbers we see here. So this is good. Okay, then we have this sort of combination one, this challenge one. So we got to think about this. If I have this part, I can work this up into two different parts, right? So if I have this here, I can multiply the top, and then whatever answer I get, I divide by what's in the denominator here. So I want to take this part and I want to do this first. I want to do the multiplication. So again, we said if we're multiplying, we can multiply our coefficients. 8.2 times 5.0. If I multiply them, I'm going to get 41. So that's a multiplication little dot right there. Okay, and then for my exponents, I have 10 to the 6th, and because I'm multiplying, right, plus -2, this is going to give me 10 to the 4th. So right now in my numerator, I have 41 times 10 to the 4th. So this is my new numerator, 41 times 10 to the 4th. And in my denominator, I still have 2.0 times 10 to the 2nd power. So now because this is a fraction, I can do the division here. So I'm going to take these and I'm going to divide them. 41 divided by 2, you get 20.5. And then I'm going to take my exponents, and because this is division, I can subtract my exponents. 4 minus 2 is 2. So this is times 10 to the second power. Now, this is not my final answer because this decimal place is not in the right position. So I need to move it where it belongs, right? Remember, it's supposed to be between the first two numbers here. So because I'm going to move this over one space here, I'm going to make this 2.05. Because I moved one space, I'm also going to have to move my exponent, add an extra one. So this is really 2.05 times 10 to the third power. Okay, and that is pretty much it with scientific notation. If we had an instant where we're subtracting them, we wouldn't add or subtract our exponents because subtraction is not the same as multiplication or division, right? Addition, subtraction is not the same as multiplication or division. So you want to make sure you're careful with that. With those, we would just simply combine like terms, or we can go ahead and expand those and do the addition or do the subtraction. For multiplication and division, this is how you can do it here.